Get ready. This concept is a total game changer, mastering tuples as keys. If you skip this, your code will definitely suffer. Ease on the screen. Notice our variable here simply named sales. This sales variable is actually a dictionary. As you know, dictionaries thrive on key value pairs. But what if a key needs to hold multiple data points? For example, pairing a country with a product. In this case, UK and laptop, or UK paired with phone. Then we map that pair to a price. Tuples are perfect for creating these composite keys. But wait lists cannot do this. You cannot use a list as a key. It simply won't work. The square brackets tell us it is a list. But these are tuples. You spot a tuple by the round parentheses and commas. If we try to run the list version, we hit a wall. Error, unhashable type list. Essentially, Python can't generate a unique hash for a list. It is just not possible, but with a tuple, it's a breeze. Since dictionaries rely on hashing, you can use multiple items as your unique key. That is exactly what we are achieving here, binding country and product together to find the price. Lists just aren't built for this role. You might wonder, why not do it another way? Why not use a nested dictionary instead, where UK is the first key leading to a subdictionary? Then you'd have another key and its specific value. Sure, you can do that, but here's the real magic. Look at this loop. It is incredibly elegant. See how clean this code looks? We extract the key and the value instantly. The key, our tuple, is unpacked automatically. By calling the .items method, we get every pair. It captures the full key value pair. The data flows directly into our separate variables. It happens completely automatically. That is the beauty of Pythonic behavior. Run this and watch the data appear perfectly. Oh, UK, laptop, and price, all as clean, separate variables. With a nested dictionary, you would need 2 loops. One for the outer country and another for the product. The code becomes cluttered and complex very fast. Nested structures add unnecessary overhead. 2 for loops instead of 1. But with a tuple, just 1 sleek loop does it all. The takeaway? Tuples make amazing keys. Lists don't. Drop a comment below. Which approach do you prefer? Both have their place, but what is your take on this? I'm about to show you a piece of Python knowledge that is absolutely essential. You may have seen this syntax before, but do you know how it actually works? We're swapping variable values, a task that seems simple but is quite clever. Under the hood, there is much more happening than you might think. Let's take variable A and variable B. A starts at 5 and B starts at 10. Our goal is to flip them so B becomes 5 and A becomes 10. How do we achieve that? In Python, it's incredibly easy. We use this elegant one-line syntax to swap them instantly. Place A and B on the left, and then on the right, we reverse the order. We want the value of B to move into A, and the value of A to move into B. When we print the result, you can see that A is now 10 and B is 5. They have been perfectly swapped, reversing their original values. It's seamless and efficient. But why does this work, and how would you do it without this special syntax? Before we dive into the logic, let's look at the traditional alternative. This helps us understand why this feature is such a game changer. We can rotate these values with ease, but to swap them, we need a third variable. We have to create a temporary variable. Think about it. A holds the value 5. If you overwrite A with the value of B, A's original value is gone forever. To prevent that, we must store A's value in temp to preserve it. Only then can we safely set B to the value held in our temporary variable. When we print this, we get the same result, but look at the extra work. We had to invent a whole new variable just to hold a value for a split second. Imagine trying to do this with several different variables. The complexity would start piling up very quickly. You'd be stuck creating temp 1, temp 2, and temp 3. It gets messy and hard to follow almost immediately. That is where Python shines. If we add a third variable C with a value of 15, the syntax holds up. We simply tell Python exactly where we want each value to go. We can send B into C, A into B, and C into A. It's a clean, simultaneous rotation of data across the line. Watch how this works in practice. Value B moves to C. Value A moves to B. And value C moves to A. If we print all 3 now, A is now 15, B is 5, and C is 10. Every value has shifted perfectly. Try doing that the old way. Your code would be a disaster. But why is Python so good at this? It's because of a concept called a tuple. Internally, Python treats these groups of values as a single unit. It packs them into a tuple, then unpacks them into the new variables. It's a beautiful process of simultaneous assignment. The values are bundled, then released. Behind the scenes, Python manages the temporary storage for you. It creates a hidden container to hold these values safely. This ensures no data is lost during the transfer. It looks like this logic. The variables form a tuple. When assigning them back, Python simply looks at their positions. A takes the value at index 0, and B takes the value at index 1. It's precise and incredibly fast. And if you had C in the mix, it would follow the exact same pattern. Each variable maps to its new position. Position 0, position 1, and position 2. Everything finds its new home. This is the internal logic. This is what makes Python so powerful. While others use long manual steps, you can use this professional shortcut. Avoid the complicated old way whenever possible. The benefits of this syntax are clear. It's cleaner and more readable. Start using it every day in your professional coding life. Can you spot the difference between these two types of syntax? I bet you can't. What we are looking at here is a Python tuple. A tuple is a data structure designed to stay exactly as it is. No matter what, it should never change. But look closely at this first example. Something very strange is happening. We have nested a mutable list directly inside of our tuple. The catch: you can modify a list, but you cannot modify a tuple. This second syntax is the professional standard. Here we have a tuple nested inside another tuple. In this setup, absolutely nothing can be altered or changed. Let's call this configuration 2. Now let's go back to the first one and try to force a new value in. We will target the items stored right here. We access position 1 and call the append method. Let's add feature C to the list. Watch this. Feature C is being appended to that inner list, and surprisingly, the code actually runs. Let's check the output before and after. I've added print statements to track the transformation. At first, we only had features A and B. Now, it shows features A, B, and C. The problem is that a tuple should be completely immutable. If you try to use this as a dictionary key, your code is going to crash. Why does this happen? Because it is an unhashable type. A hash is meant to be a permanent, unique identifier. But if you keep changing the data inside that structure, just like we did with feature C, you break that integrity. This is a massive issue because the hash changes, and your data lookups will fail every time. However, configuration 2 works perfectly as a dictionary key. When I run this, Python doesn't complain at all. This is a data structure that is truly constant. It is rock solid. Check out the output here. It successfully mapped the entire tuple as a valid key. In a job interview, using a list inside a tuple is a major red flag. Technically, you can do it, but you definitely shouldn't. It's bad practice. It fails as a dictionary key because it's just too unpredictable. But with a proper pure tuple, it works every time. Avoid the list and tuple trap. Instead, use nested tuples to keep your data secure. Nested tuples are great, but lists inside tuples are a no-go. One last thing, you can still access individual items using the standard index syntax for both methods. Let's look at configuration 2. To find this specific element, we first target the inner structure. Then we grab the very first item inside that nested tuple. We use 0 and 1 to navigate. Here is 0 and here is 1. And we can see the value 0 right here. This works for configuration 1 as well. Whether it is a list or a tuple, the syntax for accessing elements remains exactly the same. Ever spotted an asterisk in Python code and wondered what it actually does? Let's dive into this snippet and uncover its hidden power together. Right here, we have a record, and it's stored as a standard tuple. Imagine you have just pulled this data straight from a database. It contains a user ID, their status, subscription type, and location. But what if you're only interested in those first two specific items? Specifically the user ID and whether they are currently active. The remaining data isn't something you need to process just yet. So how do you handle this efficiently without the clutter? In Python, Tuple Unpacking is an absolute game changer. Here, we set up variables to capture the user ID and the status, but notice that asterisk right there. That is the secret sauce. This syntax tells Python to gracefully unpack the remaining fields. It bundles everything else automatically for you. The asterisk captures the extra data and stores it in the rest variable. This is the heart of clean unpacking syntax in Python. Here is our original record. We are unpacking it into these specific fields. The first two map directly, while everything else is bundled into one. Values like premium and EU are now mapped into that REST list. Running the code, we can instantly print the user ID and their status. It works perfectly, but look at what happened to the remaining data. The REST variable is now a list. Python grabs those items and puts them in a list for later use, allowing you to focus on the essentials first. You get exactly what you need right when you need it. And the best part, even that REST list can be unpacked even further. We can create variables for subscription type and location and extract them directly from that list. Now when we run the code, we have premium and EU ready. These variables now hold the exact clean information we want. This powerful trick isn't just for tuples, it works perfectly for lists too. In fact, our original data didn't even need to be a tuple. You can swap it for a list and the logic remains identical. Notice how the asterisk syntax still stores those extra elements straight into the REST variable without missing a beat. You are then free to unpack that data whenever you're ready. The biggest takeaway, master this unpacking syntax. It is compatible with almost every collection in Python. We have used it here for both lists and tuples successfully. Just remember, any leftover data is returned as a flexible list, ready for you to unpack and utilize later in your code. In Python, one rule is absolute. Tuples are immutable. Once you create one, no matter what you try, you cannot change it. So, how do we update our data? Imagine this scenario. We need to upgrade user 565 from a free account to a premium one. The trick is to temporarily transform that user tuple into a flexible list. We'll use a list constructor. Feed it the tuple, and it converts the data instantly. Now, our data type is a standard list. This allows us to modify index 2. Remember, we count 0, 1, 2. Position 2 is exactly where our target value lives. Once we run this and the update is made, we lock it back into a tuple using this simple syntax. Simply call the tuple constructor class. Pass the list in, and it's converted back. Another powerful method involves expanding an existing tuple. The original tuple is locked, but you need to add a brand new option to the set. We have error and typeout, but now we need retrieve. We can use the plus operator to combine them and reassign the result to our original variable. Notice how we are defining this. We are adding a one-item tuple. Watch that comma. Without it, this code will definitely fail. Let me show you why. With the comma, it's a perfect tuple. But if we remove it, everything breaks. Python can only join tuples to tuples, not strings. No comma, Python thinks this is just a string. Add that comma back in right here, and your code works flawlessly again. Now we have our new expanded tuple. Thirdly, we can utilize slicing syntax. Slicing is brilliant for extracting parts of a tuple and reassembling them on the fly. Let's start with this profile. It contains a user ID, an email address, and a token. The goal? Remove the email entirely. Watch the index. We slice from index 0 up to 1. This captures the first element, but excludes index 1. Since 1 is exclusive, the email is skipped. It's left out entirely. Now, we jump to index 2. This part is inclusive. We start from position 2 and grab everything until the end of the tuple. That includes our token. The result, a brand new tuple. Python maintains the type because the origin was a tuple. It assumes you want the same structure. Run the script and look, the email is gone. But the ID and token remain perfectly intact. Still a tuple verified by those classic parentheses. Finally, let's look at a pro-level move. Check this out. We start with our tuple. We'll extract the ID and status, then catch everything else, like subscription and location, inside this REST variable. What's the result? We get 3 clean, unique variables. Now, to update the status to active for our user, we take that ID, grabbed from the original, then we define the status as active. We discard the old value and assign this new one while expanding. This technique is called unpacking. We're pulling multiple values into specific variables. Both steps here are forms of unpacking. First, we break the tuple down into components. Then, we pack them back into a fresh tuple. Running this, we see user 565 is now active with their original subscription and their location set to EU. It works perfectly. Let's summarize your new toolkit. 1. Convert to a list and back. 2. Use the plus operator for concatenation. 3. Use slicing to surgically rebuild your data. And finally, unpack, modify, and repack for maximum control. These are the essential techniques for handling immutable data in Python. Master these and you're set. Want to create repeating patterns in Python? Say you want the letters A and B repeated. The traditional method is to write a loop. Let's see how that looks in practice. First, we'll start with an empty data variable right here. Next, we are going to construct a loop. We want to repeat the pattern A and B 3 times. That is AB here, AB there, and a B once more. We need that sequence appearing thrice. To do this, we'll loop through a range of 3. Notice the underscore, that is a throwaway variable. This is a very common Python convention. If you do not need to use the variable value, simply use an underscore instead. Other languages might use the letter I, but in Python, the underscore signals that this variable will not be used elsewhere in your code. It keeps your workspace clean. Now, we will use the extend method on our list to add the AB pattern 3 times. The code continues to extend that list and finally converts it into a tuple. While this gives you the result, creating loops and throwaway variables is actually doing too much work. This is way more complex than it needs to be. Check this out, and this is a game changer. Python allows you to multiply sequences to create patterns. This is where it gets interesting. By using multiplied by 3, Python repeats the list 3 times. Just like that, running this, you can see we get the exact same pattern, but without the headache of complex syntax. It is clean, fast, and readable. Just use the multiplication operator. Need to scale up? Multiply by 9. See how quickly the pattern expands to 9 repeating values? This is incredibly handy in Python. Forget writing manual loops for this. This trick works for lists and even for tuples. I can easily switch the data type to a tuple here, and the code still works perfectly. Run it again, and you'll see the same consistent output. Make your life easier. Use this clean syntax. Instead of that long-winded, complex approach, keep your Python code elegant. Sets are incredibly flexible. Let's master how to modify them. These 3 methods are essential for your toolkit. Meet, add, remove, and discard. But what sets them apart? The add method does exactly what you would expect. We have Sam and Brian. Now let's bring Liz into the mix. Watch what happens when we run this code. Initially, it was just Sam and Brian. After adding Liz, she appears instantly alongside the others. Pro tip: the order of a set is completely arbitrary. Even though Sam and Brian were already there, Liz might pop up at the very front. Never rely on the order. It is unpredictable by design. Don't build your logic around the sequence. This is a game changer. The order can shift every single time you run it. If I restart the environment and trigger the code again, look at the results now. Brian is suddenly first, and Sam has moved to second. This happens even though Sam was first in our input, and Liz, she's at the beginning this time. Stay sharp, order is random. This is a vital concept to remember. Now, Brian is removed, leaving Liz and Sam behind. But be careful, removing something that isn't there will cause your program to crash. If I try to remove Brian 2, for instance, since Brian 2 is missing, Python throws a key error because it can't find that item. Don't worry, there's a much smoother way to handle this. Switch to the discard method. This is your safety net. The set remains intact, and your code keeps running. We tried to discard a non-existent item, and it caused 0 errors. Unlike remove, discard is completely silent. It won't raise an exception if the element is missing. It's a much cleaner approach. Now you're a pro. Use add to grow your set, and remove for strict deletions. Just remember, remove demands the item exists, while discard handles missing items like a champ. Maximum control, 0 crashes. Ready to master Python's set operations? Let's decode exactly how this syntax works. Do you understand intersections? How about set differences? If not, stick around for this. Sets are a powerful data type in Python. Their superpower? They only hold unique values. Let's look at a real-world example. We have 2 groups, front-end and back-end. We'll start with the union operator, represented by the pipe symbol. Imagine your front-end skills include React and JavaScript, while back-end is Python. And JavaScript, notice that JavaScript is a repeated skill across both sets. Since it works for both ends, it's currently a duplicate. To get a clean list, we need to remove those repeats. The fastest way to do that is using a union merge. Just use the pipe symbol between your two variables. This instantly creates a brand new variable. And look, all duplicates are gone. Now we have a clean set of React, Python, and JavaScript. JavaScript only appears once now. Now, let's look at intersections. Intersections isolate values that both sets share, comparing front end and back end again. We have React, JavaScript, Python, and then JavaScript again. Which value is the common link between these two groups? Can you spot it? Exactly, it's JavaScript. So we expect JavaScript to be our result. This is perfect for finding developers who are proficient in JavaScript across the entire stack. It's the most efficient way to find common ground. There it is, JavaScript. Finally, let's explore differences. This operator highlights what is unique to the first set while ignoring anything that also appears in the second set. In our example, we have React in front end, and we have Python and JavaScript in the back end. Which skill exists only in the front end and nowhere else? You nailed it. The answer is React. When we run this, the output confirms it. React? This syntax essentially says, give me everything from the left side that is absent from the right side. Everything after that minus sign is excluded. The minus operator is your key to finding unique differences. Remember, these features are exclusive to Python sets. These operators won't work on a standard list. If I try to convert these to a list and run the same logic, using square brackets instead of curly braces, the code will fail immediately. It simply won't work. You'll see an unsupported operator error for the list type. It will crash your program. This logic is strictly for sets. Identify them by those curly braces. To recap, use the pipe for union, the ampersand for common values, which finds the overlap between groups, and the minus operator. To reveal the differences, master these three, and you master sets.